So again, to color code things, I'm going to do the domain and range of the original graph that was red, and then do the domain and range of the new graph. I'll use set notation this time. So if we think, what is the smallest x value on the red graph? It starts at -3, less than or equal to x, less than or equal to, and the largest value of x is 4. For the range, the smallest value of y is -2, less than or equal to y, less than or equal to 5. And then when we go to the domain and range now, I'm going to start with the range because I hope you can see that the smallest value and the biggest value haven't changed. So the range is exactly the same as it was before. But the domain is now different. On the blue graph, our smallest value is -6, and our largest value is now 8. I got that from my graph. But if you were just told the question without a graph, can you see how you could get from this domain to this domain just using your information? Okay, we're just multiplying the x values by 2. So if our smallest value is -3 and it gets multiplied by 2, our smallest value is going to become -6. And if our largest value was 4, it's going to become 8. I just want to point out that sometimes if you had chosen to use interval notation for the domain, it would look like this. And interval notation for the blue one would look like that. The one thing I find sometimes students mix up with interval notation looks a lot like a point. And so sometimes you might get tempted, oh, x by 2, and you'd only multiply the first one by 2 because you think that's my x coordinate. But in interval notation, it's not a coordinate. It's an interval from a starting point to an ending point. All right, let's go to example number 3. Here is the graph of y equals f of x. We need to now combine things. We're going to sketch the graph of 4f of -0.5x. So if we were describing what's happening, and we go from left to right, and we look, what's different in this blue equation compared to the original red equation? Well, the first thing we run into is the 4. How would I describe that 4? Vertical or horizontal? Vertical. Outside. Everything outside is y. Everything that's y we describe as vertical. That's going to be a vertical. Is it going to stretch it or compress it? You're right. Stretch by it's going to stretch it by a factor of 4. What we're going to show in our arrow is our y value is going to get multiplied by 4. The negative and the 0.5 are going to be two different things. We're going to have a reflection. And again, think if an x value is going to become negative, that's going to be horizontal. That's going to be reflection over the y-axis. Maybe you even want to write horizontal reflection. And a horizontal stretch or compression. It's going to be a stretch by a factor of 2. This will make x multiply by -2. This will mean x is going to be multiplied by a -1. When we show our arrows, we're going to put both of those together. Because if we multiply x by a -1 and we multiply x by a 2, we can combine those both together by multiplying x by a -2. As far as picking some key points, looks like our values are not going to cause us to have any fractions when we multiply, because we're not multiplying by any fractions. You always want to include this first point, because that's the starting point of your graph. So we're going to include -2, 0. If I do pick one or two other points, -1, 1, and 2, 2 seem like nice values. We can add our arrows, and this time above the arrows we have two things happening. Something's happening to the y, something's happening to the x. So above here we can write that, a reminder, we're going to multiply y by 4 and the x values by -2. What's going to happen then? This one's going to go to 4, 0. -1, 1, x by -2, that's going to become a 2. The y by 4, 2, 4. Make sure you're multiplying the right coordinate by the right value. I find for myself, when you read the equation from left to right, you hit y first and then x's. So I always seem to write y first and then x's. But when you're looking at your point, your first coordinate's x and your second coordinate's y. So it is easy to make little mistakes like that and mix things up. So just be careful. And this last one, the x by -2, -4, the y by 4 will be 8. Now that we've got those points, I can plug them in. So I'm going to have, graph them. I've got 4, 0. I'm going to have 2, 4. And I'm going to have -4, which is off of here, and +8, which would be somewhere up over there. At this point, you've got 3 points. You have some options here. Okay? Let's go. Can you see that I could either draw it this way, like that, or I could connect it this way, like that? And we're like, well, which one of those should it be? Well, in order to figure that out, I like to think about, this is a key point, right? That's a starting point. That's this one right here, -2, 0. Where did that one go? It went to 4, 0. So that is my starting point. And that's going to help me. If that's my starting point, and I need to start my pen there, then the only way I can graph it is continuing this way with the arrow going up. Another thing that I sort of do as a mental check at the end, I wrote out all of the descriptions. You know, you only have to write that description out if it says, can you describe the transformations? So you don't have to write that out every time. But in your head, you should think, do I have a vertical stretch by 4? So if I pulled it away, does this one seem to go up more than the one that I had? Have I flipped it over the y-axis? So that if I flip it over the y-axis, it would be going in the different direction. So that makes sense to me. And then has it been stretched out this way? Well, that kind of has made it also steeper like it is. So my gut feeling after thinking about each of those descriptions is that it has worked out correctly. Now we're going to add to this question. I'm going to add 2 things to this question. So why don't we just call it part B, if what we've done already is part A. We're going to add a part B and a part C. So in part B, I'm going to get you to, I'm going to use this word. I've used it a couple times today. I've used explicit equation a couple of times today. What does an explicit equation mean? That is an equation that just has y and x, no function notation. So look at that red graph. Do you recognize that from your parent graphs from before? What would the equation of our red graph be? It's a square root of x, but it's not starting at 0, 0. It's starting at -2. How would you show that? The +2 would be inside to represent that we have a horizontal translation 2 to the left. And then part C, I want to write an explicit equation for y equals, and the one that we had was 4f of -0.5x. That's our blue graph. So what we basically have is our original function is, we just figured that out in part B, the square root of x plus 2. How would I write the new equation if I have 4f of -0.5x? So what this is doing, and this is really practicing your skills with function notation. Anything outside of the function, like that 4, is going to stay outside. It's just this part that's going to be related to what we had originally. In particular, we know that whatever we put in for x replaces the x right there. So the fact that inside is a -0.5, we would write square root, and instead of where the x is, we would write -0.5x. I'll put it in brackets for now. And then we still have +2 after that. So when I write it without the brackets, the equation of that blue graph that we had would be 4 square root of -0.5x plus 2. Practicing that function notation again. 7, 9, and 10, and just like last time, I am going to do the last example, and then we'll work on both of these sets at the same time.